All right, so number one, is the relationship represented in the table a linear function? And we're going to figure out if it is or not. What is the strategy to find out if something is linear on a table? What's the strategy? Come on, guys, we reviewed this yesterday. I should see 11 people responding in the chat. What's the strategy? Yeah, how do I figure it out? I want to know, is this linear? Yes? No? What do I do? What's my strategy? We use the rate of change formula. Lauren said the same thing. We use the slope formula. Some of you guys like to cheat, not cheat, but you guys like to take a shortcut and you think it's going to be all you got to do is add, and you're like, oh, okay, plus 6 plus 9 plus 6 can't be linear. That's not how we do things. No, because remember what I said yesterday. This is not the right way to do it because it can trick you. It can trick you. You have to use the formula. So we start with the first 2 points. 11 minus 5 over 3 minus 1. I get 11 minus 5 is 6. 3 minus 1 is 2. I get 3. Then I can do the next 2 points. Now I get 20 minus 11 over 6 minus 3. What's that? 9 over 3, which is 3. Oh, so here's the deal. The problem is the reason it's not going to work by just adding is because the x values, they're not constant either. It goes 1, 3, 6, 8. There's no pattern. So we got to make sure that we use the formula because oftentimes it's going to trick you because the x values are not constant. Okay, and then the last one, 26 minus 20 over 8 minus 6. I get 6 over 2. I get 3. Okay, so any questions on how to use the formula to check whether something is linear? Okay, so again, don't just trick yourself into looking for patterns because the math never lies. As long as you use the formula, you will always know for sure. Okay, any questions? Cool. I'll leave that up. Now for number 2, we're going to write the equation in slope-intercept form for the following linear function. So what are the 2 things I need in order to write my equation?
Slope and y-intercept.
Slope and y-intercept. And Guillermo said rise over run. Yeah, we need to figure out the rise over run in order to find the slope. And then, like Ijira said, we'll finalize it by putting it into y equals mx plus b. So let's start with y-intercept because that's always the easiest place to begin. Where's my y-intercept? On the y-axis, but what is it? -2. Good. So b is -2. There's my y-intercept. Now I need another perfect point in order to find the rise and run. So what is another perfect point I can use? Three comma 0. Good. You can use any other perfect point. Doesn't matter which one. You could have used this one up here. You could have used this one right here. Any of them work. Now I find my rise and my run. And remember, I'm going to go from this one to the next one. So if I start here, I have to go up how many units? Good, up 2. And then how many to the right? 3 to the right. Since I'm going up and to the right, both of those are going to be positive. So my slope, rise over run, would be +2 over +3. And now I can put it all into y equals mx plus b form. So what would be my final equation? Good, y equals 2/3 x. And since the b is negative, we just write -2. You don't need to write plus -2. You can just make it a minus sign. -2. So those 2 questions are going to help a lot of you guys out on today's worksheet. So make sure that you understand these 2 things, because these 2 are kind of the most important part to understand. Any questions? Awesome. All right. So with that being said, let's do a quick recap of where we are right now. Today, countdown 27 days. We are on, today is Thursday. Thank goodness for that. We are on day 2 of linear functions. And tomorrow we move on to systems of equations. Now, here's a thing. I don't know yet, but I've been told that we might, next week, might have to take the iReady diagnostic, which y'all know how I feel about that. Yeah, I know. Don't worry about it. Don't stress about it. It is literally the least amount of stress that I need you guys to have, because it doesn't matter towards your grade. It doesn't matter towards you finishing algebra. It doesn't matter for any other reason other than you just have to do it because it's required. I don't know the date yet, but I believe it's going to be either Monday, Tuesday, or Wednesday. It's one of those 3 days. So I'll get back to you guys on the specific date for that. But unfortunately, it is going to cut into our review a little bit. Yeah, there's no iReady in high school. That's why I am a little annoyed, because algebra students shouldn't have to take iReady, but it is what it is. But I'll let you guys know which day it is. Okay. Again, do not stress. It is. I don't care what grade. I don't care what score you guys get on it. I don't care. I just need everyone to complete it. So we're just gonna do it and get it done, and then that'll be it. All right. Any questions on that? There's no iReady in high school. No. Let's protest. Trust me, I've tried. Okay. So today is worksheet day. Let me go ahead and pull it up for you guys. Just like Tuesday's class, you guys are going to have half an hour to work on it, and then we'll use the remaining time to go over it. And since you have half an hour, what's the maximum amount of time you should spend on one question? Yeah, 3 minutes. If you don't get it after 3 minutes, move on. I don't want you guys to spend too much time on any questions that you don't understand, because we're going to go over it later. So if you get to a question and it doesn't make any sense to you, skip it. And then mark it down or circle it so you know that you want me to go over it later. Any questions on that before I send the link? All right. Just give me a second, it's loading. You may use a calculator. And remember, when you're working on this, I want you guys to put yourself into testing mode a little bit, okay? So no distractions. Try to focus on just those 10 questions so that you can get them all done in time. And remember to think about it as if you were taking a test, because the questions on this worksheet are very similar to what you would see on a test. So the whole point is to get you guys in the habit of test taking mode. So go ahead and click on the link. It's up already. 10 questions, 30 minutes. And at the end, you guys have to let me know which questions you want me to go over together. I'll give everyone a few more seconds to get on the worksheet. There's the link one more time. And if anyone has any trouble accessing the worksheet, just make sure you let me know in the chat. Everyone's in? All right. Anaya, I know you just got here, but go ahead and click the link. We're just getting started on our review worksheet. So 30 minutes. I'm going to set the timer right now. So 30 minutes, perfect timing. We'll be back here at 10 on the dot. Go ahead and get started. Hey everybody, I'm back. I just want to say that I see that there's 9 people on the worksheet, but there's 18 people in this class. I mean, I'm no math teacher, but that seems like that's only half the students are on the worksheet, which means that half the students either don't care or aren't even here. So what I need everyone right now to do is in the chat, just say I'm on the worksheet. So I know who's on and I know who's not. So just send me a quick message in the chat confirming that you're on it. Thank you guys. And remember that if you're having issues accessing it, you got to let me know because I have other ways to send it to you. So if you're not able to access it, please let me know. Okay, continue working. Bye. Hello, I missed the halfway point, but 13 minutes, about 14 minutes remaining, so a little bit more than halfway through. All right, y'all, we're down to the last 4 minutes. So last 4 minutes, you should be on your probably your last question. 4 minutes. Alrighty, guys, down to the last minute. So finish up whichever question you're on and make sure you send me in the chat which question or questions you want me to prioritize, especially today. I don't know if we'll get to all of them. So make sure you let me know which ones you personally want me to go over. All right, that's time. Cool, start sending me, let me know which ones. So far I have 1 vote for question number 1, 1 vote for question number 8, 1 vote for question number 4, number 10, and number 5. So keep sending them because right now everybody, so far we only have 1 vote for each one. Good, 2 votes for number 8, 2 votes for number 10. Keep those suggestions coming. Take another minute or so. Just look over your work and let me know which ones you want me to prioritize. Number 9, good, I got a vote for number 9. Anyone else? Going once? Going twice? I got number 5, okay. All right, so it looks like number 10, number 8, and number 5, we'll get to those first. And then after that, number 4, number 1, and number 9. So let's go ahead and get started. I'll start with number 5. Cool, here it is. Okay, based on the linear inequality shown in the graph below, which of the following points are solutions to the linear inequality? So since we have an inequality rather than just a line, what counts as a solution in this case?
What's in the shaded part?
Good. Anything in the shaded part. What about on the line? Would it count if it was on the line? Like here? Would that
No,
count?
because the line is dashed.
The line is dashed. Okay, so since the line is dashed, it does not count. If it was a solid line, it would count. So think about it like it would fall through the cracks. If you put a point on that line, it's going to fall through the cracks. But if it was a solid line, you would be fine. So anything on the line is out. Now let's check it out. -3, 0, -3, 0, in or out? Good, out. Yeah, that one's here. 7, -5, in or out?
In.
That one's in, yeah. 7, -5, down here. That one's in. What about 4, 1?
In.
That one's also in. Right here. -2, 6. Good.
Out.
That one's, yeah, that one's out. That one's up here. And finally, -1, -8.
In.
In. Yeah, that one makes it just barely in. So none of these were on the line anyways, but just so you know, like if they had one more option and it was 0, 3, 0, 3 is on the line, so it would be out. It would fall through the cracks. The last one, how is that one in? Because -1, -8 is right here. It's in the shaded region. You have to make sure you go all the way down to the -8. Any other questions on this one? Cool. All right, that was number 5. Now I'm going to skip over to number 8. I'll do 8 and 10. Okay, another inequality question. So definitely want to make sure we study this. Which of these inequalities is graphed below? Okay, so before I look at this, you always want to start by looking at the graph and just making some notes about it. So for example, what type of line do we have? It's a little hard to tell, but yeah, it's dashed or dotted. Okay, is it shading below the line or above the line?
Below the line.
Good. What's the y-intercept?
-6.
-6. And do I have a positive slope or a negative slope?
Positive.
Good. Now you have all the information you need, and we're just going to find the matching equation, inequality. Since it's dashed and below, what symbol would I be using?
Less than.
Less than sign. So, oh, there it is, less than. Positive slope, y-intercept is -6. This matches all the criteria. It's answer choice A. So anytime you have a problem like this, you really just want to make sure you look at your graph, you write down everything you know about it, and then you match it with the correct equation. Confused with the slope. Okay, yeah, make sure that for slope, really what matters is whether it's positive or negative. And if the slope was negative, it would have been -2x. Yeah, exactly. But all of these were positive. Cool. Any other questions on number 8? Awesome. Okay, number 10. Okay, number 10 is going to take a moment because this is a really good question because it goes through a lot of information. So we have a function called f of x, and it's an equation. And then we have a function called g of x, and g of x is my table. Two different functions. They're not the same. And we're trying to compare the two of them. Well, in order to compare the two of them, we need to know a lot of information about them. So I'm going to make a little chart down here. We don't know the equation for g of x yet, but we can figure it out. So it looks like we're talking about rate of change, x-intercept, and y-intercept. So for f of x, we actually know a lot of information. Just from my equation, what are the two things I know? M is 2.
The y-intercept.
Yeah, so the slope is 2, rate of change is 2, and like Samantha said, the y-intercept would be negative. I see it in the chat, -6. Okay, that's all I know for now. I could figure out more in a little while. Then for g of x, what do I know from the table?
The y-intercept is 3.
The y-intercept is 3, good. So remember, for y-intercept, you always look at where x equals 0. What else do I know? Ooh, Jara is saying in the chat, the x-intercept would be 1, because now I look at where g of x equals 0. That's going to be my x-intercept. So if we're trying to find the x, do we put the y as 0? Yes, exactly. Yes, and we'll do that in a little bit, you'll see. Okay, so y-intercept is wherever x equals 0. X-intercept is wherever y equals 0. Any questions on those two? Oh, that's okay. All right, now the last thing I need is rate of change. And we know how to do that. We have a formula for that. So let's go ahead and do the rate of change formula. I can pick any 2 points from the table. So somebody give me one option to choose. 0, 3, okay. And then the other one. And 1, 0, okay, y'all want to go for the 2 easy ones. Perfect. So this is going to be 0 minus 3 over 1 minus 0. 0 minus 3 gives me -3. 1 minus 0 gives me 1. So my slope is -3. My rate of change is -3. So I have everything I need for g of x. Now let's finish off with f of x, because I'm still missing the x-intercept. But remember what we just noticed from the table. On a table, the x-intercept is wherever y equals 0. So on this equation, I can make y, aka f of x, equal to 0. And now I have a little equation, and I can solve that little equation and figure out my x-intercept. So to get x by itself, what do I do to both sides? +6, good. 6 equals 2x. Now, divide by 2. So x would be 3. So my x-intercept is 3. Now I can compare. Now I have all the information I need. So which one has a greater rate of change? This is a little bit of a tricky part. Let's see if you guys remember how this works. Lauren says f of x. Do we agree, disagree?
Agree.
Now she's second guessing herself.
Wait, Miss, what was the question?
Which one of these has a greater rate of change?
Oh, f of x.
Okay, why?
It's a positive number, and then g of x is a negative number, which makes it smaller.
Okay, so there's the trap that you just fell right into. That seems right, but actually the way that we talk about rate of change, we ignore the negatives because remember, rate of change is how steep that graph is, right? So even if it's negative, even if it's going down, it's actually still steeper than f of x because 3 is a bigger number than 2. So we ignore, if I'm asking you which one is greater, we aren't talking about positives versus negatives. We're just talking about how far away is it from 0. So in that case, 2 is actually smaller than 3. So it doesn't matter positives or negatives. Ignore the negatives. Just based on the actual absolute value, this would actually be a steeper slope. That's the tricky thing. Steeper. So I hate to call you out, Samantha, but the way you said it was too perfect. I had to make an example of that. But because it's very common that you're going to think that this is bigger because it's positive, but we just want to make sure that we ignore the negatives. So do I have any questions on that? Yes, as in yes, you have a question? No? Okay. All right, so g of x has a greater rate of change than f of x. It's answer choice B. Questions on this problem? Now, the thing with the negatives, that only matters for rate of change. So in terms of y-intercept, this one's greater. And in terms of x-intercept, this one's greater. So it really that little trick only matters when you're talking about the rate of change. Why is it not C? C is the function g of x has a greater x-intercept. G of x does not have a greater x-intercept. G of x has a lesser x-intercept. Any other questions on this one? That's okay. No dumb questions. We're all learning. All right. Cool. So I did all of the highest questions with the highest votes. Now I'm going to go to number 9. Number 9 had a vote. Okay. This one we didn't talk about yesterday, so I'm glad we're going over it now. Select all the values of x for which f of x equals g of x. So what is this point called? Does anyone remember? When f of x equals g of x.
Intersecting point.
Yeah, intersection point. Technically, it's called the equivalence point. But basically, it's where they intersect. So you just go to your graph, you take a look, okay, they're touching down here, and they're touching over here. And once you find those two places, which value do you look at? Do you look at the x value or do you look at the y value? Or do you're not sure?
Miss, I'm not sure.
Okay, I'm glad we're going over it. That's good. We look at the x value only. So this is 4,6, but we only care about the x value. So I'm going to check off 4. This is -1, -4. But again, we only care about the x value. So I check off -1. All right, so anytime you get a problem like this, where it's asking you, where does f of x equal g of x? We always look at the equivalence point, but specifically we look at the x value only. Okay. Questions on this one? Now, quick question, not related, but good to review. What are the two types of functions on this graph? There's two functions. What types of functions are they? One of them is linear, good. And the other one, good, is quadratic. So we have our linear function because it's a straight line. And then the other one is in the shape of a what? What is this called? It's a U shape, but it has a mathematical name. Parabola. Good. Okay, quadratic function, intersecting with a linear function. Awesome, awesome. Let's do number 4 has another vote. Let's go back to number 4. Ah, yes, this one's a good one. Okay, so a lot of words. None of them are really that important because the most important thing is which of these equations does the graph represent? A lot of times you're gonna see a word problem or just a problem that has a lot of words in it, and you on a test especially you have a little highlight button. Highlight what it's actually asking so that you don't lose sight of what is being asked of you. Yes, we've seen this before. This was on a test. This was on like your first test you ever took, I think. All right. Well, in order to write the equation, I need to know two things. What are those two things? Slope and y-intercept. Okay, y-intercept should be pretty easy. What is the y-intercept? 150. B equals 150. Now, slope might be a little more challenging because this isn't like a normal graph. This graph is a real world problem kind of graph. So the numbers are increasing by different values. Here it's going by 30s, and here it's going by 500s. So if you're going to do rise over run, you have to be really careful. But if you don't want to do rise over run, this is the type of example where it might be easier to use the formula. And I'll show you why in just a moment. So give me another perfect point on this graph. Let's make it interesting and do one of the ones over here. Okay, I have it in the chat, 3,000, 240. Perfect. Okay, and my y-intercept is 0, 150. So if you're gonna do rise over run, totally fine. If you prefer rise over run, go for it. But just remember that we're not gonna count boxes. We have to count by the actual units. So this is increasing by 30s. So if I'm going up, I'm going 30, 60, 90. And then my run goes by 500s. So I go 500, 1,000, 1,500, 2,000, 2,500, 3,000. And then once you have the rise and the run, you can figure it out. Now, like Ajira said, you might prefer to use the rate of change formula because the numbers are so big that it might just be a little bit more comfortable to use or easier to use the formula. So in that case, we would be doing 240 minus 150 over 3,000 minus 0. So either way, both ways, you're going to get the same answer. Continuing with the formula, I get 240 minus 150, that's going to be 90. 3,000 minus 0, that's 3,000. And then when I use my calculator, what do I get? .03. Good. So the slope is 0.03, which means I'm looking at answer choice A. So rise over run, you still get 90 over 3,000, either way. So yes, it was A. Nope, definitely A, because we got 0.03. We didn't get 1.03. We got 0.03. Like the M is what M is M. We're not going to add any ones to it or anything like that. Oh no. Any other questions? Okay, I'm not gonna name names, but somebody just told me that they did it backwards by accidentally. They did 3,000 minus 0 in the numerator and then 240 minus 150 in the denominator. And if you do it backwards, then you're not going to get any of those numbers. So definitely make sure, yeah, that's a very common mistake. Just remember that the numerator is always the y values and the denominator is always the x values. How did I get 0.03? I used a calculator. 90 divided by 3,000. 90 divided by 3,000 gives you 0.03. Now you could also do it without a calculator. It's just a little harder. If you do it without a calculator, I can knock off a 0. So I get 9 over 300. Then I can divide top and bottom by 3. So I get 3 over 100. And 3 100ths, that's like 3 cents out of 100 cents. So if you think about it like money, 3 100ths is 0.03. It's like if you have 3 pennies. But if you have a calculator, you might as well use it. Okay, that was number 4. Then lastly, I have number 1 on the list. So let's do number 1. And then we'll see what else we have time for, because it looks like we'll have time. Okay, so for number 1, we didn't go over this yesterday either, but I put it on here because I wanted to see how much you guys remember. So we want to find all the situations that can be modeled by a linear function. Linear function has to have a constant rate of change. And we've talked about this because there's some situations that are not linear. And that's exactly what Ijira just put in the chat. So percentages cannot be linear. So let's write this down. No percentages. And there's one more thing on this list. So we already know this one's out. There's one more thing on this list. So let's see if anybody noticed it that you can't have. Decimals are fine. We just had a decimal on the previous problem we did. Good. Lauren said it. Alyssa just said it also. What's wrong with E? It doubles. Can't have things doubling, because what happens when you double something? It means you're multiplying. So no multiplication words. What type of functions would those two be? If they're not linear, what are they? Good. They're exponential. So no factors, yeah. So if you see something like it grows by a factor of 3 or a factor of 1.5 or a factor of 1/2, whatever it is, that's a multiplication word. So I'm going to write a couple words. Doubles is a multiplication word. Factors, triples, anything that tells you that you're multiplying is going to be exponential instead. Well, now everything else is good to go. A taxi charges an initial fee, that's the y-intercept, and $1.50 for each additional mile. Addition, we're adding, totally fine. An airplane flying at an altitude of 33,000 feet, that's the y-intercept, descends at a rate of 20 feet per minute. Feet per minute, that's speed. We're good. And finally, a pizza restaurant charges $5.50 per pizza. That's the y-intercept. And 0.50 cents for each additional topping. That's addition. We're also good with that one. So all three that are good to go, it's because they have a y-intercept, they have a starting amount, and then an amount that's being added by a constant rate. Every mile, every minute, every topping, each topping. Questions on number 1? Cool. Now for number 1, let's do one more little quick thing. Just because I want to make sure we practice this. I'm going to write an equation for all three that are linear. Now remember what I said. The initial fee or the starting amount is your y-intercept. And then the rate of change is your slope. And we always look for keywords like each, per, each. Those are all keywords. Initial, that's a keyword. Okay. Those are kind of all the keywords I see. So for number 1, my equation would be y equals 1.50x plus 2. Because $2 is the starting amount and 150 is the rate of change. So it would be my equation for C. For C, yeah, what would be the equation? Remember, y equals mx plus b. Super close.
Y equals negative 20 plus
Yeah.
3,000.
Yeah, you were super close, Ajira. One more keyword I didn't highlight was it's descending, it's going down. So it's going to be negative 20x plus 33,000. Make sense? Negative because it's descending. All right, and then finally, if I'm only buying one pizza and then I'm adding additional toppings to it, then that means my y-intercept, my starting amount is $5.50, and then I'm adding 50 cents per topping. So what's going to be my equation? Good. Y equals 0.50x plus 550. So just wanted to quickly review how to write an equation from a word problem. Does anyone have any questions on this one? Cool. Now all the remaining problems, let's quickly go through them. So for number 2, we're finding the average rate of change from 2.5 to 5.5. We kind of went over this earlier in the week, but I put it up again because I know that they're going to ask this type of question. So I go to 2.5, I go to 5.5, and I use my rate of change formula. Now, which of these on a table, when the table is horizontal, which one's the X and which one's the Y?
The X is the top layer, and then the Y is the bottom.
You got it. Good. Cool. Now I just plug everything in. So this is going to be 94.99 minus 16.63. And then 5.5 minus 2.5. What do I get in the numerator? $94.99 minus 16.63. Before you just here, 94.99 minus 16.63.
Miss, isn't this supposed to be minus 19?
Oh, you're right. Sorry, 19.63. Okay.
75.36 over 3.
Good. 75.36. And then 5.5 minus 2.5 is 3. And now I just divide. So 75.36 divided by 3 gives me
25.12.
25.12.
good. 25.12. There's my rate of change. Now, the units for this one's a little weird, but let's see if we can figure it out. Remember that the numerator is the y values. So the numerator would be, what are the units?
Square feet.
Square feet. And then what's the the x values?
Feet.
Feet. So my answer is going to be square feet per feet. Kind of weird. That's okay. But just remember that even though this is a weird kind of units, you always do the y units over the x units. So square feet per feet. A lot of feet. Any questions on this one? Okay, number 3. Which table represents a linear function? So you would have to use the rate of change formula, and you want to check it at least 3 times to see if you get the same rate of change. And it turns out that it's f of x. This was on, yeah, you've seen this one before also. But for f of x, when you use the rate of change formula, you would do 19 minus 12 over 2 minus 1. That's 7 over 1, which is 7. Then you pick the next 2, you're also going to get 7. When you pick the last 2, you also get 7. And that's the only one that works out. But I wanted to use this opportunity because I think yesterday somebody asked me, what would it look like if it was quadratic? And let me see. I don't know if this one has a quadratic one. Maybe not. No quadratics on this one. Does anyone have any questions on number 3? Yeah, of course, I can show you what it would look like. So for example, a quadratic function. So let's say, actually, let me make it a little more interesting. Let's say it was something like this. It might look like this. So let's notice what some features of this table. First of all, this part right here, this 3 right here, the same thing happens on both sides of it. See that? It's symmetrical. And that's because this would be my vertex. So everything that happens on the left is repeated on the right side. And then the other thing to notice is that it's going from 8 down to 3. So here it's decreasing. But once you get to the 3, it mirrors. And now what's happening is it's increasing. So that's how you can always tell when something is quadratic, because it goes down and then back up. Or it might go the other way. It might go up and then back down. But either way, you're going to see that there's like a mirror image happening on both sides. Does that make sense? Any questions on that? Cool. And then for exponential multiplies by the same amount each time. So I don't think we have exponential on this graph either, but if we did, you could tell because it would be multiplying by the same number. Any other questions on problem number 3? All right, I want to make sure I get you guys all the answers. So let me go back. Okay, number 6. Number 6, this is the same table that we had in the bell ringer. So for this one, first thing you want to do is find the slope. And if you pick any 2 points, I'll just do these last 2. You get 6/2, which is 3. So I already know the slope is 3, which makes it pretty easy because the only one that has a slope of 3 would be A. Okay, but I also just want to quickly review how to find the y-intercept as well. And the way to do that would just be to plug everything into y equals mx plus b. I'm going to pick a point from my table, any point, doesn't matter which one. Let's pick this one because it's nice. And I'm going to plug in 6 for x, 20 for y, and 3 for m. So 3 goes in for m, 6 goes in for x, and then all I have left over is b, so I can find the value of b. 3 times 6, 18. And then to solve for b, I just have to subtract 18 on both sides. 20 minus 18 gives me 2. So b equals 2, which matches with answer choice A. So m was 3 and b was 2. Questions on number 6. Okay, cool. And then let's see, what do I have left? Number 7. Which ones are solutions? Select all that apply. We did a very similar problem yesterday. First thing you do is look for anything that's in this actual box. So 2, -2, in or out? Yeah, in, good. So A is one of them. How about -2, 8? -2, 8. That's just outside, so no. Then the rest of them are not on this graph. They're not in this box. So what do I have to do? I have to write the equation for this line, which means I need a slope and I need a y-intercept. What's the y-intercept? Well, we are going to plug it in, but we have to write the equation first. So let's start with y-intercept. What is it? Y-intercept is 4. Good. Now, another perfect point, we can use the one we already found over here. So now I do rise over run. How far did I go down? Down 3 units, 1, 2, 3. Yes, but it's going by 6. It's going by 2s. It's going by 2s. So this would be 2, 4, 6 units down, -6. And then 2 units to the right. So my slope, rise over run, is -3. So m is -3. Now I have an equation. Now I can plug all these numbers into my equation to see which one works and which one doesn't. So C, I'm plugging in -20 for y and +8 for x. So -3 times +8, that's -24. And -24 plus 4 is -20. So C is in. We got the same answer on both sides. -20 equals -20. C is in, and I'm running out of time. So the other one that's in, I'll show you guys, would be E. For E, I plug in -6 for X and +22 for Y. So a negative times a negative gives me a positive. So I got 18 plus 4 equals 22. 18 plus 4 does equal 22. So E is in. And when you try it, D does not work out. D is out. Any questions on number 7? Awesome, guys. So with all that said and done, that is it for today. As a reminder, homework is due Friday. I know a few people already did it. Good job to those who already did. But please make sure that you get it done by Friday. It's 10 questions, y'all. It's not short. So if you haven't started it yet, you got to get on it so that you don't leave it all for the last minute. So have a nice day, everybody. I will see you all tomorrow, and good job today.
Bye,
Bye,
Miss.
guys. Bye.
Chicken.
Bye.